All right, here's a good stoichiometry question. In experiment, I've got 3.25 grams of ammonia, so mass 3.25 grams. And I've got mass 3.50 grams of oxygen. And they say which is reactant is limiting reactant or limiting reagent. Just looking at the mass, I can't tell that. Nor could I tell if I converted both those to moles. I need to use that balanced chemical equation to help me with that. So let's balance it. I think we've done this one already. I think there's a 4 there and a 4 there. 12 hydrogens, so I need 12 hydrogens. That gives me 10 oxygens, so I need a 5 there. Okay. So in order to determine which is the limiting reagent, what I like to do is I like to start with either this one or that one and figure out how many moles of the other one I need. So let's do that. So we're going to find, we're going to take mass of ammonia and convert it to moles of ammonia. Okay, so my formula, moles is equal to mass over molar mass. The mass is 3.25 grams. The molar mass of ammonia, let me do that over here. So 1 nitrogen is 1401, and 3 hydrogens are 101 each, so that's 303, so 17.04. So 17.04 grams per mole. Okay, calculator. So I need to go 3.25 divide 17.04. So that gives me 0.1907, etc. moles of ammonia. Okay, so that's how many moles I have of ammonia. So now let's figure out, if I had that, how many moles of oxygen would I need? So I would need then 0.1907 moles of ammonia times, do the dimensional analysis, so 5 moles of oxygen divided by 4 moles ammonia, so times by 5 divided by 4 would be 0.2384, etc. moles of oxygen. So that's how many I would need. Now let's see how many do I have. So how many moles of oxygen do I have? Okay, I can figure that out easy. Moles of oxygen would be equal to the mass over molar mass. Mass is 3.50 grams. The molar mass of oxygen, it's just 2 O's. That's 16 a piece for 32 even. So 32.00 grams per mole. So I have 3.5 divide 32.00. That's 109,375 moles. So this is how many moles I have. If I was using ammonia, I need that many. But I don't have that many. I only have 0.109. I don't have 0.234. Therefore, oxygen is my limiting reactant. Okay, step A done. Okay, so now let's do step B. How many grams of nitrogen monoxide are formed? Okay, so now I just need to do my whole stoichiometry thing. So I'm starting here, and this is the ammonia side, and I'm looking for mass of nitrogen monoxide. So this side is my nitrogen monoxide side. So it's going to be a 3-step question. 1, 2, 3. So first, I have to take the mass of ammonia, not ammonia, because that's not my limiting reagent. Oxygen is. Mass of oxygen, and I want to convert it to moles of oxygen. Well, I just barely did that, so it's right there. Okay, so moles are 0.109375 moles of oxygen. Okay, Step 2, get across the river. So step 2, let me shrink things here a bit. Whoops. Shrink things a bit. There we go. Step 2, dimensional analysis. So moles of oxygen to moles of nitrogen monoxide. So I have 0.109375 moles of oxygen times 4 moles nitrogen monoxide for every 4, not 4, because it's oxygen. I always want to go back to that ammonia. 5 moles of oxygen. So I have to take that same number I had and times it by 4 and divide by 5. So 0.0875 moles of nitrogen monoxide. That's what's going to be produced with this much of my oxygen. Last step is to get to solids, so I'm going to take my moles of nitrogen monoxide and convert it to mass of nitrogen monoxide. Formula, moles is mass over molar mass. Mass then is moles times molar mass. So the moles are 0.0875 moles times by the molar mass of nitrogen monoxide. I think I just did that. Nitrogen was 1401 and oxygen, one oxygen is 16, so it's 30.01. 30.01 grams per mole. So take that number I just had and times it by 30.01, and that'll give me 2.625, etc. grams, rounding it to 3 sig figs, 2.63 grams. Yeah. Okay, so how many grams formed? Done. B's done. Then it says how much of the excess reactant remains after the reaction. That's an interesting question. So if I look back here, this is how many moles. The excess was the ammonia, right? Oh, up here, I shouldn't have had that as ammonia. This should have been oxygen, because oxygen was my limiting reactant. Okay, but let's see what we have up here. So I have this many moles of oxygen, and I have this many moles of ammonia. So what I need to figure out is how much of the excess stuff of the ammonia do I have left. So here's, and I can use dimensional analysis to help me figure that out. Let me move that back up there a bit. Okay, so excess reactant. So if I have 0.109375 moles of oxygen, I can multiply, do dimensional analysis. So my reactions here, I'm going with oxygen and ammonia. So it'll be 4 moles of ammonia and 5 moles of oxygen. So if I multiply this out, this will tell me how many moles of ammonia actually get used up. So, what was that number again? Oh, okay, 3.5 divide 32. That gives me my 0.109375 times by 4 divide by 5. So 0. I saw that number somewhere. Oh yeah, 0.0875 moles of ammonia. That's how much ammonia would be used up. It's interesting that this number is the same, but this one, it's the same because this one was nitrogen monoxide on the right side, and I'm going to ammonia, and it just happened to have the same coefficient. So 0.0875 moles of ammonia got used up. But initially, how many moles of that stuff do I have? So it looks like I have this many moles of the stuff. So to figure out my excess, I take how many I have. So I have 0.1907, and I used up 0.0875 moles in the reaction. So if I subtract those two, let me subtract that. Subtract I come up with 0.021875. That's how many moles were used up. And the question just says how much of the excess. No, this isn't used up. This is how much I have left. This is how much I have. This is how much I got used. So when you subtract them, this is how much is left over. So that's how many moles are left over. If you wanted to figure out how many grams that would be, then you can just use your formula to figure that out. We might as well do that. So if I wanted to convert that to grams, it'd be moles is equal to mass over molar mass. So mass is moles times molar mass. Moles 0.021875. Moles times by the molar mass of ammonia, which is 1704 grams per mole. So times 17.04. So it'd be 0.37275. That's how many grams would be left over of the ammonia. Okay, hopefully that helps you with that question number 7.